All right, ladies and gentlemen, welcome to a not very entertaining but very educational video on multiplying fractions. To start this off, we're going to start with page 100 in the textbook, and we are on number 3.4, which is multiplying decimals. So we're going to take a look at how we would get this. Now most of you know already that we can do a simple area of a rectangle. And the example we just did on the show me boards as a class, I said give me a rectangle that's 3 by 5, and most of you could go that 3 times 5 equals 15. Or if I were to actually draw this into squares, that I would have 15 squares, or it would be 15 units squared, like that. But we're going to take it a little further. We're going to go right into decimals. And we're going to use some physical models to help us in the form of base 10 blocks. The first problem it gives you is it says, using base 10 blocks and grid paper, use base 10 blocks to model a rectangular patio with an area greater than 4 meters and less than 6. Now this part I found confusing. It said, let the side length of the flat be 1 meter. I had to read this a couple of times until I realized that it meant that this is a square meter, and that the length of one side is the length of one flat. So I have 1 meter by 1 meter. So if I'm designing a patio, it says more than 4 meters. I have a patio that is 4 meters square. But it says here that I want to have more than 4 meters. I now have a patio that is 5 meters squared. 1, 2, 3, 4, 5. But I could break this into smaller pieces. Do you remember these blocks, grade 7? How many of these fit into one of those? 10 of them. How many of these little guys fit into one of those? Okay, so right now I'm going to extend my deck. I'm going to put in a few extra boards. So I now have 5 square meters and 1, 2, 3 tenths. 3 tenths in the tenths place. And that's meters squared. But I could also use these little pieces, and I could extend my patio like this. I now have 5 meters, 3 tenths, and 6 hundredths. It's more than 4, but it's less than 6. So as you can see, you could do many different variations as you go throughout. So here we have an example in the textbook where it has 2.5 times 1.7. Now, it says here that we have a rectangular park, and it measures 1.7 by 2.5 kilometers. So this is representing a park. It's 2.5 kilometers by 1.7 kilometers. So we have 2 kilometers and 5 tenths. 1, 2, 3, 4, 5. 1 kilometer and 7 tenths this way. And then we're just filling out the rest of the rectangle because we know that we are multiplying the side by the length to get the whole area. So let's look what we have. We have 2 whole kilometers squared. How many tenths? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 tenths. Well, let's write this down. I have 2 whole kilometers right here. So I got 2 kilometers. How can I write down 19 tenths? How can I write down 19 tenths? Yes, Miranda? 1.9. Because if I look at this, when I count up 10 tenths, 10 tenths is another whole. That's the 1. And then we have a whole 10 of them and 9 more. And then I also have 35 singles here. Do you see the 35 singles? That's, how much is each one of these? How much is each one of those?
1
That's a hundredth. You got it. Thank you. So I've got 35 hundredths. So if I add up the wholes, the tenths, and the hundredths, I'll have the complete area of the park. So I've got 2 wholes, 1, 2, 1.9, because it's 19 tenths, 35 hundredths. So add them up, 005, 093. Got to carry that 1. Our park is 4.25 kilometers squared. So what that means, if I took all these pieces, I could fill up 4 1/4 of these to get the space of that park. Now the next thing we're going to look at is we're going to change it, pardon me, I'm just showing the camera that's recording, into a model like this here, and I'll show you on the camera in the class. And I want to show you how we can change this into that sort of model. So here we go. I have a park that is 1.7 by 2.5 wide. So this measures 1.7. This measures 2.5. When I look at this model, I have 2 whole pieces there. Do you see how I have 2 whole pieces just like that? Pardon me, I should make it a little better. Like this. So I have 2 times 1 kilometer squared. 1 kilometer, 2 kilometers. How many tenths do I have right here? How many tenths right there? I have 5 tenths, okay? So I've got 1, I could say 5 times a tenth. How many tenths do I have here and here? How many tenths? 7 here and 7 here. Okay, so I have 2 times 7 tenths. Are these tenths or hundredths? Hundredths. Those are hundredths. And I had 35 of those. So I've got 35 times a hundredth. All I have to do now is put these all together. 2 times 1, that's 2. What's 2 times 0.7? 1.4. What's 5 times a tenth? 5 tenths. You got it. What's 35 hundredths? Now I need to add it all up. So I've got 2, 1.4, 0.35, and 0.5. If I add that all up, I have 5. 4, 3, and 5 is 12. Carry the 1, and it's hard to see, but it says 4.25. So we have 2 models. The park is 2.5 by 1.7. We did it with blocks, and we did it with boxes. Now the boxes are a little difficult to understand. We're going to take a second look right here, and then we're going to do one on our own. So I'm going to pause the video while we do one on our own. To wrap up our final example, we just did a number of examples on the board, but it's shown here in the textbook where this, instead of an area like the ground, is shown as how much a person would pay for grapes. Sorry, I keep pausing. Here we go. We have 2.95 times 1.8. But instead of area, we're actually talking about that every kilogram of grapes costs $2.95. How much would 1.8 kilograms cost? So once again, we're multiplying. It's this per kilogram times that many kilograms. But we're doing the same box method. So we have how many wholes? We've got 2 wholes. So it's 2 times 1 whole number right here. This, once again, is just figuring out the dimensions of each square. If we have 2 counted for here, then the dimensions are 0.95 times 1. Right there, 0.95 times 1. Here the dimensions are 2 by 0.8. We've accounted for 1 here. We have 0.8 left. 2 times 0.8. The remainder is once again the dimensions, which are 0.95 and 0.8. Find the area of all these rectangles, as is done here. Add them up, and you have your total cost of grapes is $5.31.